Okay, so now we're going to have a wee look at some excess calculations. And what we'll do is, let's have a look at this first one. What I'm going to do to start with is I'm going to tell you 3 steps I use when I do an excess calculation. Let's find it. Okay, my 3 steps for this are: 1, to calculate the actual number of moles for both reactants. Second of all, I would use the mole ratio to compare, then find the limiting reactant or the one that's in excess. Then I would write a statement to basically prove what you've written. Okay, and that's how you answer these kind of questions. So let's start with this one. So we've got 0.4 grams of sodium sulfite, and that is reacted with 50 centimetres cubed of dilute hydrochloric acid with a concentration of 1 mole per litre. That means the 2 things we're interested in are the sodium sulfite and the hydrochloric acid. So I'm going to take them out and I'm going to put them into a kind of simplified equation. My bad, I've just copied the wrong thing. SO3, and that goes to 2HCl. That means it's a 1 mole to 2 mole ratio. First of all, I'm going to start with calculating the number of moles of my acid. So that's going to be N equals CV. The concentration was 1 mole per litre from the question, and the volume was 50 centimetres cubed. So we divide that by 1,000 to get into litres. 1 times 0.05. So that means we have 0.05 moles of HCl. Now I'm going to work out the number of moles of my sodium sulfite. And remember, that's SO3, not S2O3. It's mass over gram formula mass. It tells us we've got 0.4 grams, and the GFM is 126.1. That's given to you in the question, mass of 1 mole, GFM. That means our number of moles here is 0.003. Okay, so we've done the first step. We've found out the number of moles of each, the sodium sulfite and the hydrochloric acid. What we're going to do is we're actually going to work out how much we would need for each of these. So if I had 0.003 Na2SO3, I would need 0 volts. Because it's a 1 to 2 ratio, I would need double that of the acid to be able to do that reaction, so I would need 0.006 moles of HCl. Now that would work because that is less than what we actually have, the 0.05. That would work. However, if I used 0.05 moles of acid, I would need 0.025 moles of Na2 volts. Not sure what's happening there. I am just going to score that out because I messed that out. Now that would not work because we only have 0.03. We would need a lot more. So that means this is the limiting reactant. So that's not going to work. So the acid in it is in excess. The Na2SO3 is a limiting reactant. And you could even, if you wanted to be specific, you could say by how much. So we are missing 0.025, take away 0.005. is a difference of how much we are delimited. So that would be 0.022 missing. So that's fine, you've said which one is in excess. Okay, I'm going to do the next one, and I'm just going to work through the same steps. It's a very similar question, the next one, so I'm not going to actually kind of say anything. First of all, I'm going to tell you what the product X is. It's going to be water because it is a condensation reaction which produces an ester, so it's going to be water. Okay, let's work out this. So two things we're interested in are benzoic acid and methanol. Oops, I'm trying to get that on the page. So let's work out the number of moles for each. It's 5 divided by 122. Let's work out the number of moles of this. Okay, so we've worked out our actual number of moles that we have. What we're going to have to do is we're going to basically see what we need to, we're going to compare the ratios now. So if I had 0.04 moles of benzoic acid, I would need 0.04 moles of methanol. Now that would be possible because I've actually got 0.078 moles of methanol. So I've got more than that. That means the methanol is in excess. That would work. However, if I try to use 0.078 moles of methanol, then I would need 0.078 moles of benzoic acid, which I do not have. I've only got 0.04. So that means I am 0.078 take away 0.04. I'm just going to calculate this quickly. I'm missing so it's limiting reactant. There you go. So we have shown that benzoic acid is the limiting reactant because it is missing enough to react with that full amount of the acid. And also you could argue, if you're saying that the methanol, you could argue that if you've got way more methanol and that's in excess, then that must mean the other one is a limiting reactant. So that should be fine. And remember, you're just following those 3 steps when you're doing these limiting reactant or excess calculations.